Hello, and congrats for making it past for loops. So in this third segment, we'll talk about a new type of loop called the while loop. Then we'll go over a useful tool known as a list comprehension. So the syntax of a while loop is pretty simple, and it's illustrated here. While some Boolean condition is true, colon, new line, indent, do some code. As you can see, there's a lot of similarity with the for loop structure, especially in the way that this loop forms a code block using indentation. But there's some differences, and this is a flowchart of how while loops work. So when first entering the loop, the condition is checked, and that condition has to be a Boolean or a Boolean expression. Now, if that condition evaluates to true, then you run one cycle of this loop, you do that action, and you go back to the start. Now, on the other hand, if that condition evaluated to false, then Python wouldn't even enter the loop. But once you're in the loop, it keeps cycling, with each cycle checking that the condition still evaluates to true. If it does, it keeps cycling, but if it ever evaluates to false, then the loop ends. You might be thinking, what happens if it never ends? And that's a real issue. While loops provide, of course, one easy way to get an infinite loop. So in this example here, the condition will always evaluate to true because it's true. So the loop just keeps running this action until eternity. Just something to be aware of. Oops. Here's a more useful while loop, though. So here we want to print all of the powers of 2 that are under 1,000. So we start by setting the base and an exponent of 0. And then we initialize a variable to keep track of the current result, which starts at 2 to the 0th power, which is 1. So this while loop starts by checking whether this Boolean condition, which is result less than 1,000, is true, and it is. So Python enters the loop. Now it prints the value of result, which is 1, and then it calculates the next power by increasing exponent by 1, and then it recalculates this result, which is now 2 to the first power, or 2. Then goes back to the start, checks whether 2 is less than 1,000, which of course it is, so it prints 2, it increments the exponent, and now it calculates 2 squared, which is 4. And so on until result becomes 1024, which is at the end of the 10th cycle. And since 1024 is greater than 1,000, the condition finally evaluates to false, and this loop will exit having printed powers of 2 all the way up to 512. Okay, so that's the while loop. It's useful, you should know it, but in all honesty, I don't have to use them very frequently. The last thing I want to share in this segment is something that I do use very frequently, which is called a list comprehension. You think of it as a compact alternative to creating new lists using for loops. So for example, what if you wanted to create a list that contains the first 10 perfect squares, those being 0 squared, 1 squared, 2 squared, 3 squared, etc., up to 9 squared? Well, you create an empty list, call it squares, and then you'd use a for loop which reads for every value, num in range 10, append num squared to the list squares. And that gives you the list squares below. 0 times 0 is 1, 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, etc. Okay. So I guess I lied about being done with for loops. But in any case, there is a faster way to write that, and it's called this list comprehension. So it's a single line where we set the variable squares to this expression enclosed in square brackets. And that expression becomes a list. And at the end of that expression contains this familiar for loop syntax from the previous slide, for num in range 10. And the start of that expression actually has that simple calculation, num squared, where num represents the values in range 10. So indeed, it gives the same answer as list, which is pretty magical if you ask me, just one line of code. And that's list comprehensions. We'll go into this in more detail in the Zoom class sessions, but for now, That's the end of the segment. It's a shorter one, hopefully. And we have one more segment on if statements coming up.